Hello student, I am Latif sir. Today I will discuss about ICC class 9 chemistry. The topic is language of chemistry. This is my second video on this topic. So today I will discuss about radical, classification of radical, molecular formula, and how to write molecular formula and significance of molecular formula. So let's see what is radical. Radical is an atom or a group of atoms of the same or different element that behave as single unit with a positive or negative charge. Radicals are generally classified in two classes: acid radical and basic radical. Acid radical means negatively charged radical, that is anion, and basic radicals are positively charged radical, that is cation. Acid radical are generally nonmetals. Nonmetals form acid radical, and basic radical metals are generally forms basic radical. For example of acid radical are chloride ion Cl minus, nitride ion N3 minus, oxide O2 minus, hydroxide OH minus, sulfate SO4 2 minus. An example of basic radical Na plus, Mg2 plus, NH4 plus, ammonium ion, hmm, aluminium 3 plus ion, Al3 plus ion, etc. Now, classification of ion or radicals depending on their number of charge. Classification of ions or radicals depending on the number of charges. The number of charges indicate the number of electron lost or gained by the atoms or by the atom or group of atom. Depending on the number of charges, 1, 2, 3 or 4, then the ions or radical are classified as monovalent, divalent, trivalent, and tetravalent respectively. Depending on the number of charges, if number of charges plus 1, then then the radical is called monovalent radical. If number of charge is 2, then the radical is known as bivalent radical. If 3, trivalent. If number of charge is 4, tetravalent radical. Now, list of common electrovalent positive radical, that is basic radical. So four types of basic radical. First, monovalent electropositive radical. Example: monovalent means charge is plus 1. Example of monovalent electropositive radicals are ammonium NH4 plus, Q plus, Cu plus, mercurous Hg plus, generally Hg2 2 plus it is. Okay. And now bivalent electropositive radical, that is the charge is plus 2. Arse example: arsenite, argentic Ag2 plus, argentic Ag2 plus, ferrous Fe2 plus, stannous Sn2 plus, cupric Co2 plus. Now trivalent electropositive radical example are aluminium Al3 plus, chromium Cr3 plus, arsenic symbol is As3 plus. Now tetravalent electropositive radical. Tetravalent means charges plus 4. Plumbic Pb4 plus, stannic Sn4 plus. Now list of common electrovalent negative ions, that is acid radical. Four type of acid radical or electrovalent negative ions or radicals. First, monovalent electronegative radical. Example: acetate CH3COO minus, permanganate MnO4 minus, bisulfite HSO3 minus, bisulfate HSO4 minus, cyanide Cn minus, hypochlorite ClO minus. Now bivalent electronegative radical, that is charges 2 minus, For example, carbonate CO3 2 minus, oxide O2 minus, sulfate SO4 2 minus, silicate SiO3 2 minus, chromate CrO4 2 minus, oxalate COO whole twice 2 minus. Now, trivalent electronegative radical. Example, arsenate As5O4 3 minus, As5O4 3 minus, phosphide P 3 minus, phosphide P3 minus, phosphate PO4 3 minus, borate BO3 3 minus. Now tetravalent electronegative radical. Example, carbide C4 minus, ferrocyanide FeCN6 4 minus. Okay, you can see also the Selena book of chemistry book of Selena publication. There are many more radicals are given. You should just see the name of the radical and their symbol. Okay, molecular formula. What is molecular formula? A molecular formula, also known as chemical formula, is a combination of elemental symbol is a combination of elemental symbol and subscript numbers which is used to show the composition of a compound. For example, water is represented by H2O. Here in water, two hydrogen atom and one oxygen atom present. Silica is represented as SiO2. So molecule of silica is symbol of symbol of one molecule of silica is SiO2. Marble is represented as CaCO3, calcium carbonate. Sulfuric acid represented as H2SO4. Hydrochloric acid HCl. Nitric acid HNO3. Sodium hydroxide NaOH. Potassium hydroxide KOH. These are molecular formula. How to write molecular formula? Before writing molecular formula, you have to know the different types of radical. It is most important. You have to know the symbol charge of the radical. So you have to memorize, you have to remember the symbol or charge of the symbol of the radicals first. Now, how to write molecular formula or chemical formula? There are four steps mainly in the writing of chemical formula. First step, write the symbol of a basic radical to the left. First, you have to write the symbol of basic radical to the left hand side and that of acid radical to the right hand side. The first rule or first step is you have to write down the symbol of basic radical to the left hand side and symbol of acid radical to the right hand side. Next step, write the valency of each of the respective radical at the right hand top of its symbol. In the next step, you have to write down the valency of each respective radical at the right hand top of its symbol. Now third step, divide the symbol valency by their highest common factor HCF, if any, to get the simple ratio. Ignore, you have to ignore the charge plus or minus. You have to ignore the charge. Okay. Now fourth step, step 4, cross the reduced valency. If reduced valency is 1, then ignore it. If a group of atoms receive a valency more than 1, if 1, then ignore. If more than 1 valency, if a group of atoms receive a valency more than 1, then enclose it within brackets. Remember the four steps. Now, now let's see the example. First, how to write the formula? The first step is you have to write down the symbol of basic radical to the left. Here two example is given for a symbol of molecular formula of magnesium chloride, molecular formula of ammonium sulfate. Let's see magnesium chloride. Here two radical are present, magnesium 2 plus a basic radical, and Cl minus is a chloride radical. This is acid radical. So first, the first step is you have to write Mg2 plus to the left and Cl minus to the right. Okay. Now put the value of valencies to the right, top right. Okay. So I have written Mg2 plus, the valency is 2, and Cl 1 minus, valency is 1. Okay. You have to ignore the charge. Now uh, find out the HCF of 2 and 1. Then HCF is 1. Now divide the valency with this HCF. HCF is 2. So divide, in case of magnesium there is valency is 2. So divide 2 by 2. Then 2 by 2 is 1. So here written it is written that Mg1. And in case of Cl minus 1 minus, so valence is 1, then you have to divide it by the HCF. So 1 divided by 2. Okay, to get the simple ratio. So here Cl2, just interchange the valency of magnesium with chlorine, and valency of Cl with magnesium. So here it is seen that Mg1 Cl2, and it is mentioned in a step that if the number is 1, you have to ignore. So Mg1, you have not to be right the value of 1, value 1. Okay, so the formula of magnesium chloride is MgCl2. Now in case of ammonium sulfate, you have to remember the formula of ammonium radical and sulfate radical. First, ammonium radical means NH4 1 plus, and sulfate radical means SO4 2 minus. Now interchange their valency. So 2, the valency of sulfate 2 comes into the lower subscript of NH4, that is NH4 whole twice, and the valency of NH4 1 plus, that is valency 1, comes into the lower subscript of SO4, that is SO4 whole 1, and you have to ignore the value 1. So the formula of ammonium sulfate is NH4 whole twice SO4. Now significance of molecular formula. Molecular formula represent the name of the substance. Second, both the molecule and the molecular mass of the compound. You will able to calculate the molecular mass of the compound by seeing the molecular formula only. Okay. Third point, the respective number of different atoms present in one molecule of a compound. For example, in MgCl2. So one magnesium atom, two Cl, uh, two chlorine atom. Okay, that's why the respective number of different atoms present in one molecule of a compound. And the last point, the ratio of respective masses of the elements present in the compound. Next day I will discuss about chemical formula, a chemical equation. Yeah, okay.